Hi, everybody, and thanks for the introduction. First, I would like to thank the organizers for giving me the opportunity to present our HitS services at this conference. In today's presentation, I would like to draw your attention to our fragment screening and hit validation capabilities. Today, I want to first give you a general introduction to WuXi AppTec's HitS platform. Afterwards, there will be some general considerations about fragment-based drug discovery. And then, in the main part of my talk, I will walk you through our HitS service portfolio, ranging from protein engineering and production, biophysical screening and hit validation, to structural biology. There will also be some additional information about follow-up services that we can offer to progress your drug discovery projects. Furthermore, I will also introduce you to a new product line, ready-to-go assays, which will help you to minimize the time you spend on hit validation. WuXi AppTec's HitS platform is a newly built business unit, which is a part of WuXi's research service division. At the beginning of 2020, WuXi's DEL screening unit joined forces with Germany-based TRIC, a 100% subsidiary of WuXi AppTec. As you can see, we can offer services at the early stages of drug discovery projects and support our clients, especially at the target and hit finding stage. Our key expertise lies in customized protein production, screening, especially DNA-encoded library screening, or short DEL, fragment-based screening, and respective hit validation, as well as structural biology. This is mainly done by X-ray crystallography, but we also ran first successful cryo-EM projects. As you can see, HitS is operating globally. Our DEL team is based in Shanghai, and we've also built up a biophysics and screening as well as a crystallography unit there. In addition, we have a protein production facility in Suzhou. TRIC, where I am based, is located in Munich, Germany. We are producing customized proteins, and it is home of our state-of-the-art biophysics platform and of our newly refurbished crystallography department. In addition, we have a fully operational DEL lab, and we distribute DEL kits from here all over Europe. The same holds true for our Boston site. We have also a DEL lab, and DEL kits can be processed there directly. This talk will mainly focus on fragment-based screening, but if you're interested in our DEL capabilities, I'm happy to invite you to the presentation of my colleagues Alex Satz. First of all, some general considerations about why we offer fragment-based screening. One reason is that it is quite complementary to classical HTS, as offered, for example, with HTB, or DEL screening, the second screening technology we offer within HITS. In fragment screening, we are working with rather small molecules with a rather small size, around 200 to 300 Daltons. Due to their size, they can bind to small pockets as they are available, for example, on protein surfaces, a good starting point to block protein-protein interactions. However, first hits show normally a rather low affinity in the 2 to 3 digit micromolar range. One big advantage is, though, that fragments are quite simple chemical starting points. This allows for more flexibility during the hit-to-lead optimization stage. The fragment hits can be grown, ideally supported by structural biology, so we typically recommend our clients to structurally enable all their projects. They can also be linked or merged. This enables a very efficient way of sampling the chemical space. And this chemical simplicity of the fragment is also very helpful to efficiently optimize the pharmacokinetic profile together with the potency of the hit. Before we dip into the experimental details, just a few words about the rationale behind the design of the fragment library. We set up a library that comprises approximately 3,100 fragments. The library was designed with strong support from our MedChem experts at WuXi. The library contains molecules from the eMolecules library, lab network, and there are also some proprietary fragments from WuXi AppTec. To select appropriate fragments, we applied various filters to remove frequent hitters and known false positives, as well as molecules that are known to interfere with the assay formats or harbor unwanted reactive groups. All the fragments are synthetically accessible, show appropriate complexity, and are of course rule of three compliant. In summary, we selected a representative assembly of key pharmacophores, and in the end, the selected list was also manually curated by our MedChem experts. On this slide, you can find in-depth information about the physical-chemical properties of the Fragment library. If you're interested in more detailed information about the library, please feel free to get in touch with me. I'm, for example, also happy to share the ASD file so that you can have yourself a closer look at the fragments that can be found within our library. But for now, let's take a step back and talk about the starting point of all biophysical screening campaigns, the protein production. At HitS, we offer customized protein production solutions. We tailor proteins towards the needs of the screening format. We offer recombinant protein production from E. coli, yeast, insect cells, and mammalian cells. Depending on the respective needs, we produce either full-length proteins, if possible, of course, or specific domains, always keeping in mind that structural information is very powerful to efficiently drive a drug discovery program. Since Crystallography, which is now a part of the HitS platform, is historically a structural biology company, we have very high standards and QC criteria when it comes to protein quality. For every lot that we prepare, we run SDS page and analytical sec to check for purity and monodispersity. We do intact mass and mass spec fingerprint to check for protein identity and post-translational modifications. And last but not least, we check for protein activity, making use of our biophysical assay platform. Methods we are using range from simple thermal shift assays over MST and SPR to biochemical activity assays. In summary, we always produce proteins that are the best possible solutions for the downstream process. In this case, the screening approach. Just to give you an idea about the expertise we gained over the decades, please find here just a couple of examples of targets we've been working on in the past. In total, we produced more than 1,200 assay-grade proteins and 250 crystal-grade proteins, for which we have verified crystallization protocols. Traditionally, we worked a lot on kinases, but these days, the requested targets become also more exotic and challenging. In the last years, we worked on several membrane proteins, such as GPCRs, ion channels, and secondary transporters. But also DNA and RNA binding and modifying proteins are really en vogue at the moment, such as helicases and nucleases, as well as immune modulatory proteins. Once sufficient quality and quantity of the most important reagent, and protein is to some extent nothing else than an assay reagent, is available, we are getting to the biophysics and screening stage. On our biophysical and biochemical assay platform, we offer more than 10 different assay formats. We are able to run a full characterization of your compound series. Currently, for fragment screening and hit validation, our main working horses are microscale thermophoresis, in short MST, SPR, nano DSF, or classical DSF respectively. With these methods, we are able to offer fast turnaround times. We also have the flexibility to change between different assay formats. As you all know, some proteins tend to behave well in SPR, but not in MST. For others, it's the other way around, and some others only work in DSF. Combined with our protein production colleagues, we have optimized starting material in hand, and we can check for the best possible assay format. And only once we identify the best protein assay combination, we will start the screening campaign. With this platform, we do not only identify hits, but we can characterize them in detail. We can check for parameters such as KD, thermodynamics, or kinetics. Besides our working horses, we also use NMR, ITC, DLS, ASMS, or FP as routine assay formats. As of note, and as a sign for our continued close collaboration with Nanotemper Technologies, we are an officially certified provider for microscale thermophoresis. As I mentioned before, we think that the choice of the appropriate assay is also somehow guided by the target protein. Our two mainly used technologies to run our fragment library are SPR and MST.
Here you can see a comparison of both technologies. First, SPR. In SPR, the target protein is immobilized on a chip surface. This can either be done through covalent linking using NHS or melamine chemistry, or in a non-covalent way, for example, by capturing a protein via its HIS tag. However, throughout the years, we made very good experience with biotinylated protein that is immobilized on a streptavidin-coated chip. Preferably, we biotinylate our proteins using an AppTec. Interactions of the fragments to the target are measured on an optical biosensor. The throughput is pretty similar to MST and lies in the range of a few thousand molecules. Advantages are low protein consumption, high sensitivity, and accurate affinity and kinetics measurements. Disadvantages can be the immobilization to the surface, leading to a decrease in stability for protein and activation, as well as solvent effects on signals. In contrast, microscale thermophoresis is a method to measure ligand binding free in solution. More precisely, the motion of the protein along a temperature gradient is measured. This motion is affected by charge, size, and solvation entropy of the protein. Upon ligand binding, at least one of these parameters is changed, and a KD can be plotted. Advantages are low protein consumption, high sensitivity, and that binding is measured free in solution. Drawbacks can be that a fluorophore is required, and therefore covalent or non-covalent modification of the protein. At HitS, we have two fully automated screening devices for SPR and MST. On the one hand, a BioCore 8K, a high throughput 8-channel system. A couple of thousand of molecules can be screened with an affinity ranging from picomolar to millimolar. In single dose mode, several hundreds to a couple of thousand molecules can be tested. Afterwards, 12-point KD values are determined. A similar throughput can be achieved by the automated MST instrument. We have a fully automated screening unit in-house coupled to a liquid handler. KD values in the picomolar to millimolar range can be determined. Several hundred compounds per day can be tested in a single dose, and approximately 80 KD values per day are determined. We also recently expanded our MST capabilities and invested in the new Dianthus device from Nanotemper. The assay principle is very simple and still based on microscale thermophoresis. However, the assay was transferred from glass capillaries to a 384 well plate format, what was a big leap forward. This will dramatically increase the throughput. We tested the device extensively, and we see very nice correlation between capillary-based and plate-based instruments. So nowadays, we also run on this device routinely our screening campaigns. Currently, we are looking at a throughput of 1,500 compounds per day in single dose and 150 full KD values per day. And I think we will further improve the assay format and can even extend these figures. Now I want to give you a more integrated overview about our screening process. This is how we typically run a screening from gene to validated hit. First, we produce the protein and run QC by SDS page, SEC, and MS. Then we use Nano and DSF to optimize assay conditions. We screen for an assay buffer in which the protein is happy and check for detergent and DMSO sensitivity of the target. We also check qualitatively for protein activity by analyzing tool compound dependent increase in the protein stability. Based on this information, we do an extended assay setup. We are testing which of our key technologies, SPR, MST, and Dianthus, is most suitable for the screening. Once identified the best assay format, we run a single dose screening at typically 500 micromolar, followed by an affinity ranking of the identified hits. Depending on the specifics of the project, this can take between 2 to 6 weeks. Afterwards, the identified hits are validated by an orthogonal biochemical or biophysical assay. We also recommend our clients to start setting up a suitable crystallography system in parallel. This could either be a soakable or a co-crystallization system, because we are all aware that structure-guided drug discovery is the most efficient way forward. Further down the road, we can support you with SAR by catalog or with in silico approaches. Both will be done within the WuXi family. After presenting you our general screening workflow, I want to draw your attention to a new product line at HitS, ready-to-go assays including MST, SPR, nano-DSF or biochemical assays. With this service, we want to make the know-how that we generated over the years available to our customers. We do not only offer the assay know-how, but also HitS produced proteins that are tailored for the specific assay formats. These constructs could either include full-length proteins, complexes, or individual domains. The tagging strategies are designed to allow for optimal assay performance. Most of the proteins you already have on stock, so we can start analyzing your compounds once you ship the material to us. These assays can also be nicely combined with our fragment screening capabilities. You can either use our in-house library or also external libraries. All sorts of different interactions can be analyzed here. Protein small molecule, protein-protein, or protein nucleic acid interactions. Depending on the project scope, data can be available after 1 to 2 weeks after receipt of the material, but we can also screen larger number of compounds at competitive timelines. Please also note that most of the targets are also established in our crystallization department, so that we can take your ligands from biophysics to structural biology immediately. The list contains usual suspects as KRAS or EGFR, but also challenging targets like NLRP3, polymerases, membrane proteins like ion channels or transporters. For more information, please reach out to me. In the following 2 slides, I will show you some real-life data on a case study we performed. Here we produced the C-terminal soluble domain of the simulator of immune response genes in short sting. In the construct design, we included an AVI and a HIS tag so that small molecule binding could be analyzed by SPR and MST. We established a labeling strategy in MST using the RADTRIS NTA dye labeling the HIS tag non-covalently. For assay validation, we analyzed binding to 2,3-CGAMP, the natural substrate. We observed a binding affinity in the low nanomolar range, which is in very good agreement to the published data. We ran a primary screening at 1 concentration, followed by subsequent KD affinity ranking. The best fragment hits we identified exhibited binding affinity in the 2 to 3 digit micromolar range. From assay development to identification of hits, this took us approximately 4 to 5 weeks. For orthogonal hit validation, we made use of other assays that we established in-house. On the one hand, SPR immobilizing sting via biotinylated AVI-tech and nano-DSF. We could confirm in total 66 binders. In the meantime, we also established a soakable system in crystallography, which worked nicely for the native ligands. Somehow, soaking of the hits turned out to be challenging. Now we are pursuing a co-crystallization strategy. After we faced the soaking issues, we decided to validate a subset of our hits by STD NMR. And here the data were really encouraging. We could confirm 9 out of 11 selected hits. After biophysical screening and hit validation, typically a next step in these kind of projects is structural validation of the hits by X-ray crystallography. This we can also offer at HitS. Since I'm running short in time, you can find here a general overview on the crystallography workflow. In the ideal scenario, we establish a soaking system for the target protein. This enables us setting up soaking experiments at very high compound concentrations. These experiments we either run in-house or directly at the synchrotron, depending on the number of hits. The data are automatically processed and identified hits are manually refined. In case of success, this opens up all possibilities of structure-guided drug design and then would involve our medchem experts from WuXi. In summary, I showed you that WuXi AppTec's HitS platform provides a one-stop shop for drug discovery programs in the target-to-hit phase. We produce high-quality, customized proteins for DEL and fragment screening campaigns, a key factor for a successful project. Fragment-based screening is suitable for challenging targets, efficient sampling of the chemical space is possible, and often new, unique binding sites can be identified. At the HitS Biophysical platform, we offer a tailored solution for your target. Once hits are identified, these can be orthogonally characterized, biophysically, biochemically, and by structural biology. With this, I would like to conclude my presentation. I would like to thank you for your attention and happy to answer your questions.